Hi there. So in this video, we want to talk about percent problem applications. Hopefully you've seen the previous video where we just talked about percent problems without wording to them. Okay, and so this is a good example of the kind of thing that you'll see. So in the past winter term, I had a class with 32 students enrolled. On the first day, 28 of those students attended. So what percentage of the class first attended? All right. So if you remember the way we solved percentage problem is we talked about the ratio of the part to the whole equal to the percent over 100. Okay, and see there was kind of just a general form with those problems where it was pretty easy to see how to fill things in. Okay, and so what you want to do whenever you have wording and things aren't worded in that format, then what you want to do is just first of all, the very first thing, and this is true in general with problem solving, always ask what you're trying to find and make sure you know specifically what you're trying to find. Okay, and the key thing we're trying to find right here is that if you read through that wording, we're trying to find the percentage of those that attended. Okay, and I'm abbreviating here just to save some time. All right, and so we're looking for the percentage that attended. So the key thing to notice right there is we're looking for the percentage, and so we're looking for this right here, the percent in that equation. Okay, and so that helps you get started. That's going to be x over 100, like that. And now what we need to do is we need to fill in numbers for the part and the whole. Well, what is the whole? The whole is the class. Okay, and then what part are we looking for? We're looking for the part of that class that attended. Okay, and so 28 people attended out of 32 total. Okay, and so now we have our proportion that we can solve, and so here's our cross products. Hopefully you're getting used to this. All right, and so we do 28 times 100. That's 2800 is equal to 32 times x, so we just write that as 32x. Okay, and then to isolate the variable, we divide by the coefficient in front, which would be 32 in this case. So if we type in 2800 divided by 32, we get 87.5. All right. Now again, this is just like the last one. So there's going to be another layer though whenever we're trying to find the part in the whole in future problems. Okay. But what are we trying to find? What is this 87.5? It's the percentage of those that attended. Okay. And so remember, we always include units. Okay. And so the units for this problem would be the percent. Okay. And you want to say what that is too. And so those are the percent that attended. So at the very least, you might even write more of a complete sentence there. But you want to, whenever you have a problem in words, you want to answer the problem in words as well. So there's our first example. Okay, so here's another problem. Whenever you stay at a hotel in Oregon, you're taxed at 1.5% of the room rate. Okay, so what that means, if you're unfamiliar, whenever you see a price for a hotel room, they take that price, but then they compute 1.5% of that and add that to the bill. Okay, so two questions we can ask from this. Okay, part A, if you stay in a hotel room that costs $105, then what is the tax? And then we'll be able to use the answer in part A to see what the total that you'll pay for that hotel room. Okay, and so in order to get started with part A, just try to focus on this idea of a percentage is the part to a whole. So you have the part to the whole is equal to the percent over 100. Okay, now what are we trying to find here in part A? We're trying to find the tax. So now the key thing is to figure out which one of these three things the tax is. Well, if you think about it, you have your room charge, and then the tax is a small part of what you're charged. Okay, and so in terms of what we're trying to find mathematically, we're trying to find the part right here. Okay, and so that's what we want to set equal to x. And then what does that tax come from? It comes from the room rate. So the room rate is the whole. Okay, and then the percentage is 1.5, all right, out of 100. Okay, And so now hopefully you see that we have a proportion, right? And so we have these two cross products right here, and so we want to equate them. So you have x times 100. We could write that as 100x. And then we do 105 times 1.5. You do that on your calculator, you'll see that you get 157.5. All right. And then now we have an equation to isolate x with, so I would divide by 100 here. With that, if you need to, you could use your calculator to do this, but 157.5 divided by 100 is 1.575. Okay, now we got to think about this problem. All right, what are we trying to find? Okay, and you know, what is this x representing? And this is a big advantage to write what you're trying to find. It tells you this is the tax. Okay, and over here it was the part. So the tax, what is the tax in terms of units? It's a money amount. Okay, and so the tax here. Now you might, since this is a money amount, it's 1.575. Now, whenever you have money, though, you got to think money always goes to the hundredth place. So we actually want to round this up. So the tax is actually $1.58. Okay, and so that would be the answer to part A. All right. Now just realize that is added on to the bill. So then for part B, the total is going to be the room rate plus the tax. Okay, like that. And so what is that going to be? That's going to be 106.58. Okay, like that. What kind of units does that have? That's also a dollar amount. And so that's the total that you're paying is 106.58. All right, so here's another problem using one of my computers. Okay, and so this is a report on how much storage or memory I have on my computer right now. So it says 5.63 gigabytes available of 121.12 gigabytes. So two questions we can ask is what percentage of the storage is available and what percentage is taken. Okay, and so so in part A, what are we trying to find? We're trying to find the percentage that's available, right? Okay, and so that just helps us guide us if we think about this normal template here. A part over the whole equals the percent over 100, and since we're trying to find the percent right here, that's what's going to be our variable x. Okay, and then what is the part? That's how much is available, how much memory is available. So that's 5.63. All right. Like that, out of the whole would be the entire amount of memory. So that's going to be 121.12. Oops. 121.12. Okay, and so then hopefully this is becoming repetitive. Once we have that proportion set up, then I equate my cross product. So I do 5.63 times 100. That's 563 is equal to 121.12 times x. Okay, and so now we need to isolate our variable. Like that. And so we do that. Now be aware with, practical problems, things very rarely come out nice and neat. And so, yeah, and so what we're going to see here is we're going to see a very long decimal here. We end up getting x is equal to 4.64 828 2695. Okay. Now you could just remember what we're trying to find here is that's a percent, and so that's how much is available. Oh boy, I need to clear up some space on on that computer, don't I? Yikes! I didn't notice that just from the numbers. That's pretty amazing. Now again though, you can round these too whenever you have these long decimals. I would just round to the tenth. Okay, and so you could just say or about 4.6% is available. Okay, we don't really want to round to the whole number with percents. A lot of times that's just a little bit too far off. So either way you want to answer that, or maybe you just want to circle it off. Okay? Now for part B, there's kind of a shortcut to this, all right? There's two ways you could do this. As far as the part goes, we're trying to find the percent taken, okay, like that. So to get the percent taken, if you just wanted to follow this same format, the part to the whole, the part's going to be the amount that's taken, though. And see, there's 5.63 available, and there's 121.12 total. So I would need to subtract those two to get the amount that's taken. That ends up being 115.49. Okay, and so you get 115.49. Everything else is going to set up the same. All right. X over 100. Okay, like that. And then you could go through and solve. But there is a shortcut here. Okay, either storage is taken or it's not taken. And so here I have about 4.6 that's available. Well, in terms of percentages, what is the total in terms of percentages? The total is 100%. So I could just subtract that 4.6 from 100. So the other way I could do it is do 100 minus 4.6. And then, you could to be really accurate, you would do 100 minus this very long number right here. But if we're willing to accept that rounding, so then that ends up giving me about 95.4% is taken. Okay. Now you don't have to do it that way. I'm just showing you the shortcut. You can go through and do it just like the last problem. By the way, I don't know why I numbered that last example, number 3, but anyway, let's see. So let's look at another example. So a company report says that 18 people started work late on a particular day, which was about 20.9% of all the employees. And so you see that report and you don't know how many employees work there, and you might just get curious. And so you can use this information to compute how many employees work at the company. Okay, so let's see how we could do that. All right, and so again, what are we trying to find? We're trying to find the total number of employees at the company, but at least this much, right? Like that. So we're trying to find the total number of employees, and that just helps you figure out what to fill in for your variable and what numbers go where whenever you're trying to set things up here. Okay, and so notice, first of all, it's pretty obvious we were given the percent, so that's going to be 20.9 over 100. Okay, and the key thing is, especially if you use good wording on your find line, we're trying to find the total number. So that's going to represent the whole. So we're trying to find the whole, and the part is the 18 people that showed up late. Okay, now the other way too to understand the part in the whole here is looking at this 18 people. We're talking about 18 people, and they're only 20.9. So this is only part of all of the total number of employees. So that's the other way to recognize that 18 is actually the part. And so then in that case, you would have had the part and the percentage filled in, so you know you're trying to find the whole. Okay. So again, hopefully it's getting a little repetitive. There we have a proportion now that we can cross multiply by, and so we get 20.9 times x is equal to 1800. I just wrote those out of order the way I usually do. I usually do multiply these two first. It doesn't matter which way you multiply these, as long as you do your cross products and set them equal to each other. Okay, now this one's going to be a little bit interesting. We're going to do 1800 divided by 20.9 on our calculator. Okay, and to isolate x, notice that we need to divide by 20.9. Okay, but look what x comes out to be. You might want to pause real quick and compute that. We get 8.6. Okay, so now hopefully you just caught something. I started to go back and just delete this whole segment, but I noticed a mistake. Okay, that I saw this 8.6 and I kept talking for a moment, if you noticed, but you heard me start stuttering because I saw that. Okay, why does this answer make no sense whatsoever? Okay, that we had 18 people that started work late on that given day, and we're asking about the total number, and that's even less. Okay, what I did is I mistyped the 20.9 on my calculator, and so I decided to keep this segment just to remind you that you got to think about answers whenever you get them. So it's a good lesson here. All right, and so if I really do 1800 divided by 20.9, okay, I get 86.12. Sorry about that. That's a good lesson. Okay. The other way you catch that is there's a few things to point out with this. Okay. First of all, that answer seems to make more sense. And then also, what is this X representing in this problem? And this is a big advantage to writing out what you're trying to find. It's the total number of employees. So this is saying 86.12 employees. But the other thing is, too, is, there's people are counted in the whole number. So this 0.12 doesn't make sense. And if you look at the wording up here, which was about 20.9%, okay? And so what you want to say is there's about 86 employees, and that's what I assume there is, since that is so far away from 87, okay, like that at the company. All right, so usually if it's not possible to have that decimal number, we round it. Now if this had been 86.72, we would have said about 87 employees. Or if you're not real sure, you could say between either 86 or 87 employees. By the way, too, I haven't talked much about checking. Another big, especially with word problems, another big checking technique in word problems is whenever you think you have the answer correct, I would use this to check with, by the way. What you can do is you can pretend like the problem gave you this and that it gave you one other piece of information, and then go and compute the other piece of information and make sure that that checks, okay? And so, if I wanted to check this, I pretend like I'm solving a different but a related problem. I would say that if I'm given 86.12 employees and 18 didn't show up on time, right? Like that, then what's the percentage? Like that. And so in that case, I would do 18 over 86.12 equals X over 100. Okay, and so and then you would go through with the solving there, and you can see there ends up, if you go through and do that, I'm trying to save some time, but then we get that comes out to be about 20.9%. Okay, and so about, remember we often use those squiggly equal signs. Okay, so that one does check. So anyway, that's just a good checking technique when word problems is once you think you have an answer, what you can do is you can pretend like a problem gave you this one other piece of information, and then go through the steps to find the other piece of information and make sure that it's the same as you were given. All right, so let's look at some problems where you're asked about percent increase or decrease. Okay, and so let's see. Okay, so here's an example that we're seeing a bit too much of these days, right? But say you have a particular kind of milk that you like to get. And so a store was selling your milk for $2.45 per gallon, but is now selling it for $2.75 per gallon. So by what percent did the price increase? Okay, like that. And so the key thing is that we're talking about percentages and we're talking about increase. Okay, and so again, try to focus in on what you're trying to find. We're trying to find the percent increase, okay, in price if you want to be more explicit. So whenever we're talking about percent increase or decrease, then we have this idea of part to the whole equals the percent over 100. But just remember from that from the last video, in these kind of problems, the part is the increase. On increase problems, it's the decrease on decrease problems, okay? And then the whole is the starting amount, where it started from, okay? like that. So then now that'll help you because we're trying to find the percent. So we're going to have X for our percent, like that. Now our part is the increase. This one might not be so obvious here, but the key thing is it started at $2.45. It went to $2.75. So if you ever have trouble seeing what the increase or decrease is, you just subtract them, the larger minus the smaller. So we got 2.75 minus 2.45. So that ends up being 0.30, or just 0.3 if you wanted to. Okay, so the part is 0.3. Just be careful on these problems. The whole is the starting amount. So it started out at $2.45. Okay, and so now we have our proportion again, so we can equate the cross products. And so we do 0.3 times 100, that's equal to 30. All right, and then we get 2.45 times X. All right, and again, we can just isolate X by dividing. This is going to be one that probably doesn't come out perfect here. So we get 30 divided by 2.45. That's that. And so what we get here is we get X. Your X is over on the right side, but that doesn't matter. So we get 12.24489 796, like that. And you don't necessarily have to write out these things, though. You just got to remember that what is this? What are we trying to find? We're trying to find the percent increase right here. So this is actually a percent. And like I was saying, typically we try to, with percentages, we try to at least go to the 10th place. So we would say that there's a 12.2% price increase. Okay, like that. Or you could say percent increase in price. But the key thing is you're talking about percentage of price. Okay. The other thing too is always think about units. If we had been looking for either one of these, our answer would have been in dollars. But since we're trying to find the percent increase, then our unit is the percent there. All right. So let's just do one more. So say there's a store. They have an appliance. They've been selling an appliance for $510, but they're having a 30% off sale. Okay. And so what is the sale price? So this one's a little bit tricky in terms of what kind of problem we're solving. But the idea here is that we have that 510, okay, and it's being reduced by 30%, okay? And so just make sure you realize another word for reduce is decrease, okay? And so what this problem is, this is a percent decrease problem, okay? Like that. And so whenever we think about setting up the part to the whole is equal to the percent out of 100, okay, just remember in this problem we're given the percent. So we have 30 over 100, okay. Now what are we trying to find here? Okay, we're trying to find the sale price. Okay, now we won't be able to find this directly from this technique. Okay, what we can do to find the sell price, we need to find the decrease. If we know how much it decreased by, then we could just subtract that from 510. Okay, and so remember in these parts, in these kind of problems, the increase or decrease is the part. So that's my X. Okay, and then what's my whole? It's the starting amount. This thing started out as $510. Okay, and so now I have my proportion, so I equate the cross product, so X times 100, that's 100X, and then 510 times 30 is equal to 15,300. Okay, and then to isolate X, I divide by 100. Okay, and so X is equal to 153. Now, what is X here, though? We need the decrease, and so X here, the other way to see that, too, that you may not have worded all that out. So X, where was X? It was here. It was in the numerator, and the numerator is the part. But since we're doing a percent decrease problem, the part is the amount of decrease. Okay, and so 153, this is the amount to decrease. So then to get that sell price, okay, To get my sell price, I take what I started with and I subtract that 153. All right, and so then 510 minus 153 is 357. Okay, and so my sell price is $357, and that's the answer to the problem. Okay, so it's a pretty long video, so I'm going to leave it there. Let me know if you have any questions, but I do hope that helps, and all the best.